Right. Let's see. It's on the right. Yeah, it must be on the right input. There it is. Okay. Good morning. Welcome. I am a couple minutes behind this morning, but I am ready to get going now. So for anybody new, my name is Tim. I go by Foamy on GitHub Discord, and I stream at this time of week, pretty much around 10 a.m. Central Time. On Saturdays, working on some CircuitPython stuff. If you are new and you don't know what CircuitPython is, you can learn more. The main website for it, circuitpython.org. This is basically a version of Python that runs on tiny computers called microcontrollers. There are a bunch of pictures of them over here. Essentially, you can either hook them up to other little bits and bobs, peripherals, lights, buttons, beepers, buzzers, sensors, radios, any kind of little electronic widget that you can imagine. Typically, you're going to be able to connect that up with a microcontroller and then interface with that widget, write programs that interact with it. And for the devices on this page, there's 558 of them. If you choose to use CircuitPython with them, then the way that it tends to work is you plug it into your computer with a USB cable. It goes up like a thumb drive. You can edit the Python code file that's on that thumb drive. And then as soon as you save it, the microcontroller will actually interpret and execute that Python code for you. So that's the sort of 50,000 foot view of what I typically work on. Today, what I am diving into is this Stanford EDU project, I guess. In the 70s, they created this thing. It's an idea for teaching programming. It's kind of like a little robot character that you can control, and there's tasks like pick up the blue thing and put it down in certain spots, and walk through the walls and does stuff like this. So I am going to see how far we can get trying to implement this with CircuitPython and Display.io. So that's what I'm going to work on today. And I have created some very, very, very rough basic assets to use. So I am actually just going to start by saving them. Actually, before I even jump right into that, let me indulge myself on one other thing and show you here if anyone might be interested in this. Like how we have a GIMP thing. I wonder if I could make that default somehow. All right, this is totally unrelated to Karel the robot, but it's something interesting, I think, and something I've been messing with the last couple of days. So the Advent of Code has started in December. There's a website called Advent of Code where you can get like programming challenges, essentially. Each day, there's a different one. There's a different two, actually, because each day has two different ones. Anyway, this one is from, I think, yesterday or the day before. The challenge was basically a guard with a very basic movement pattern. He can only kind of go forward or turn right, and he just turns right if he runs into an obstacle, if he would run into an obstacle. It did specify, my bad. The guard is walking around, and there are a bunch of obstacles in the way, and you have to kind of figure out which paths the guard will not be on. The idea being you're going to like sneak back in time or something. You're trying to avoid the guard. You don't want to go to the places where she is going to walk. And this is a visualization of my data. We can load up PyCharm as well. I'll run it one more time, but then we'll get on to the actual Karel stuff. So totally unrelated, but I thought it was neat that I was able to not only solve the challenge on a microcontroller, but I was also able to kind of visualize it with Display.io like this using a bitmap. That looked pretty cool. Okay. I'll rerun it once here. We can watch it rim around. So you can see it just goes forward and turns whenever it hits an obstacle. The obstacles are kind of like the little gray pixels. The red is the path that the guard's taken, and then eventually there's one green pixel, which is where the guard exits the full map. Is what we were trying to find in one part of the challenges from whichever day that was. How's it going, Jose? Nice to see you, my friend. Okay, so let me get this one out of the way. We're not going to actually use that anymore, but I thought it was cool. I'll see. I did one other one with a visualization on CircuitPython as well. In fact, that's right here. There we go. So that's nice. This was from a couple of days before. I don't remember if it was the one day before or 2 days before, but it's a different one of the challenges. This one was like a word search where you're trying to find the word Xmas, or in this case, you're trying to find the word MAS, kind of in a diagonal tic-tac-toe type pattern, essentially, with an A in the middle and 2 M's and 2 S's. And this one is colored in where like each M is green and each S is red and each A is white. Something like that. I don't remember the exact colors, but that's the idea on this one. And it's the same deal. It's just running the Advent of Code solution and then visualizing it using display.io with a bitmap. Is again pretty neat. See how many more of them actually lend themselves to that. I know at some point, at least last year, which was the first year I really did Advent of Code, they did scale up to the point where you either need much more efficient means of solving them or bigger computer than what the microcontroller is going to offer. So we'll see how far I get trying to do them. I don't remember. I think it's like day 6 maybe. I think this was yesterday, but I'm just gonna guess. I don't actually know. Okay, and then I'm actually just gonna go back to empty hello world pretty much because I'm gonna be putting a lot of this in a different thing. I guess we could put in lib. So the first thing to do is kind of get it appearing on the screen. Well, really the first thing to do is I should save this. Probably save both the here, the folder side of it. Okay, save that. Let's export it also. We could export it as now, I think. A bit more RAM than a bitmap, but $898 bytes. Spreadsheet in the library, can we? So I'm gonna try to keep this relatively true if we can to the syntax. The syntax they say is from Karel.StanfordCarel import star. So what I'm gonna try to do though, I think I'm gonna just change up Stanford Karel to be in display.io Karel or CircuitPython Karel. I guess probably CircuitPython Karel. So I'll make the package Karel. We will need init, but then we will have CircuitPython Karel, and it will import star. And one of the things So let me think about this. So my true instinct is to make this a class with like a self.Karel and a map and a tile grid and a bitmap and all kinds of things. But the truth is they don't have it as a class here. They just import everything and then they call these functions, which effectively all have side effects in the world, which means the world just kind of has to be... I mean, there can still be an object under the hood, right? Move can just say Karel robot dot whatever. Uh, yeah. Yeah, we just have an interface that is the functions that exist outside the class as well. Okay, so one of the very first things, I think I'm gonna make a I think I am gonna make a world and a Karel class and then try to get that rendering. And they say, yeah, they use the term world to represent the environment you're in. So I am gonna make world. It's gonna extend extend group. And it's gonna do a bunch of things. So when you initialize it, it's gonna call super it. So it's going to make a self dot background. I think I'm gonna do background bitmap, which is going to be a bitmap that is 16 by 16 and is only really needing one color for right now, but maybe we'll change that eventually. I'm going to aim for kind of just the basics we need. I'm going to try not to write too much of it in my head before we get anything down. So we will have that bitmap. We'll have a palette. Background palette. It's going to be palette with the one color, which we'll set to white. Okay. We need a tile grid as well. So I'm on a Pi portal. It's 320 by 240. My tiles are 16, so I can fit 15 technically. By 20. Let's start by just doing that. By 20. So actually going to do this slightly differently. This is a bit awkward, but what I'm going to do is go 20 by 15 here. Then make a background tile grid. Oops. Can import. Oh, because it's tile grid with a capital G. Oops. No. Okay, still wrong. Here we go. And then I am gonna scale it. That in it. Okay, so we have a background. We need to work out the display. I think that I want this to accept the display. That's how we're gonna do that, and then we'll just put self.display equals display. We need a world group, self.world group. So this one will be, no, we do not, because we are a group, in fact. I mean, we don't have to extend group. I guess we could just have a group instead of be a group. Is there any reason, one way or another, we should do that? I mean, for one thing, I feel like it's a bit odd to be a group and then have a display which holds the group that you are. That's, I guess there's nothing inherently wrong with it, but it feels kind of wrong. So I think I'll do this way. We'll have a world group equals a new group, which is not scaled. And then world group is not going to append itself to itself because that doesn't make any sense, but it's going to get the background group instead, which is scaled. So we should have a white background inside of this. And the display is coming in, so we're gonna set display.root group equal to world group. So that should show it, and then when this gets imported, because we want all the setup magic to happen on import, we are gonna go and make a new world. World. Yeah, later on, I'm gonna try to think about what to do about external displays, but right now I'm just going to pass board.display and assume it exists, because it does, because I'm on a PyPortal. So that will create that, which should set it showing, and then if we just import this from Karel.CircuitPython Karel import all, and then while true pass, do we get a white background? Yes. Beautiful. Okay, we need a... I'm gonna make another class. Class Karel is... Karel is going to... send... thing, or should we do it like world and it just has tile grid? I'm gonna start by extending tile grid and see if anything gets weird. I think I want to do that. Init args. Do I think actually I do. I think I do not want to extend tile grid actually, because I want to be able to set the X and Y in cell coordinates, not pixels. We are going to get past the sprite sheet bitmap and the sprite sheet palette. And we will have a tile grid made from those two things. And the default tile is going to be, in the default tile, we can just do 0. Probably already, but I'll set it for now. And we'll be changing that as we turn. So we're going to have a direction. We need to keep the bitmap and put it on the tile grid. I don't think we do. So the direction by default is going to be west. No, it's east. Yeah, I'll reorder these later. We'll see. I don't remember how the turning works exactly. By default, we're going to go east. We have a direction. We have our tile grid. Later on, we'll worry about the beepers, the things you can pick up. For now, I think that's maybe all we need. Can set some more stuff up here so we can say sprite bitmap is that actually. So we actually, both of those, we're gonna say if I save sprite sheet in here, is it gonna find it? Relative. Okay, one thing well, let's just see what the transparency does. Transparency will just, well, it's not gonna work because it's green. We need to make it indexed and then tell it to ignore green. But let's try to see if it actually renders at all. Create Karel Then we add Karel's tile grid to the self tile grid to the world group. Does that crash or the rope such file? So I think it's still searching in the root, which is fortunate. If we do this, will it search in the directory that the code is in? Directory. I mean, I would rather not code like lib Karel. I guess we could. Does CircuitPython have like underscore file or whatever? Is that a thing in this? Is it a thing on regular Python? Yeah. Okay. I mean, you know, it's not what I want to do necessarily, but this should work. We could say like libdir is file dot split on the flash on basically reconstruct the first two, and we could replace, I suppose. Ah, I'm not printing the right thing. Okay. Maybe that worked. We know. Lib. Oh, what I expected. Huh. I only want 2 parts of it. Spacing does thought? Anyway, whatever. It returns what we want. And then we want still a slash in the end, but we can just put that back in here. Sure. That anymore? Not support. That means maybe we put green as 0. Good morning, C. Grover. Device again. There we go. Did not crash. Did draw the entire sprite sheet. exactly what I wanted. Oh, I think this needs to be tile width 16, tile height 16. There we go. Okay, now we have Karel going to the west. Transparency, so we want the sprite sheet palette transparent on 0. Run. Just got here, so Karel's like an alternative to Turtle Graphics. In a way, sort of. It is kind of similar to Turtle Graphics. It's interesting you mentioned it. Yeah, I didn't really go into the background of where this came from in my head, but yeah. So there's a bit of a similarity, I would say. Not necessarily an alternative because it doesn't really draw, so it's not paint-like necessarily. Whereas Turtle is kind of a programmatic paint in a way. But that being said, that is exactly where this idea came from. All the way back in 2019, Willing C left this little nugget here. Implement Karel the robot. I don't know what this is about. It says I pushed a commit that references it. I don't know why that would be the case necessarily, but that's where the idea came from. And it is similar in that you drive it around with a similar interface. It's not the exact same. Like Turtle, you can turn by angles, right? Like you can say turn by 45-degree angle and then move and stuff like that. This one only goes on 90s and it doesn't leave a trail where it's moving, and it's really mostly just a learning mechanism to be able to learn the core concepts of programming, functions, loops, logic, debugging, iterative development, things like that, which you can learn a lot of that stuff with Turtle as well, especially if you build some constraints around it, like, I'm going to try to make the Turtle, do this or whatever. This is giving you a little bit less rich of a world. There's not quite as many things as you can do. There's not as many degrees of freedom, so to speak, with the angles and everything. And you're a little more constrained on what you can do. But yeah. Okay, so that was working, right? Yeah, okay, so we have Turtle, transparency's working. All right, we need a world tile grid. Right now we have a world group and we have a background bitmap and a background tile grid, which is the white part. We need a world tile grid, which is gonna hold all the tiles in the world, which can be either walls, like these are walls that you're not allowed to walk on. The X's are, the plus signs are, they call them corners, which I would say is like probably my biggest gripe with the language they use so far. Corner is, I get it, I guess, because it's a corner of the XY axis, but corner feels very confused. Like if every single one of these grid cells is a corner, then like what's this one and what's this one and what's this one? What's this one? Are those like, those are corners of the box, which I feel like makes the term corner a little bit confusing, but I'll probably just use the same words. We'll see. But we need a tile grid to hold all of that stuff. So we need to do it after the sprite sheet. I mean, we might as well do it after the sprite sheet. I guess need is a bit strong. We should do it before Karel because we do want Karel to be on top. The robot will be the top thing in the Z index. So we might as well do our world tile grid before that. So right now, I'm just going to make it size of the screen, which we found earlier, conveniently enough, is 20 by 15 tiles. Oh, but this is not the right thing. This should be 16. That should be 16, and then width should be 20. Height should be 15. And I'll just do the plus sign as the default tile, which is 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Yeah, 5th index. And that's enough to just world. Oh, we already have the group. Come on. What are we doing here? The code completion AI LLM thing or whatever in here is like, it's good at some stuff, but you get into some territory it doesn't understand, and it starts suggesting some pretty blatantly not the correct solution things. But blatant is relative, I suppose. All right. There's our Karel. There's our world in it. At some point, we will be able to define the world when you create it somehow. So I don't know how that's going to look exactly just yet. And in fact, it's one of the spots where we actually get to, where we have to kind of use our own creativity a bit, because there's really nothing here that defines the world. The world just exists somehow. So we'll need to rectify that, because I want the library that I'm writing to be able to be used with any world, right? So somehow we need to input the world, which isn't happening here, but we will cross that bridge when we get to it. Next up, let's work on the movement, question mark. Yeah, let's work on the movement next. So we have a world, we have a Karel, we created the world. World created the Karel. We're gonna say def move. I'm gonna go look back at the docs. Yeah, maybe we'll spawn a beeper after this, but we'll work on move first. So let's just get move going. So move will take one step in the direction that you are facing. So actually, I'm going to start by saying I'm going to make properties here. So Karel is going to have an X property, which is going to be returning the X value in cell coordinates, not pixels, which would be X, but then over, I think 0 move to 16 would be 16 over 16 is 1. Yeah, I think that's what we want. We're gonna have setters as well, actually. Like new value. I don't know if it's that much of a difference, but all right, and then let's do the Y's. Okay, so now we can get and set our X and Y of Karel in the cell coordinates. So we can very easily just go like, I mean, this is a somewhat naive way to do it, but it works. If we use the right values for east and west and everything, we could maybe get this to work without the whole if statement. I think I'm just going to leave the if statement, though, because I feel the code is clearer. So if we're moving east, which we know we are, then we go world.karel.x plus equals 1. We'll worry about constraints later. At some point, you know, I think it actually raises an exception if you go outside, maybe. Is that the case? This is saying move, pick beeper, move. But what if we go, is it turn? How do we, yeah, turn. There's actually a turn left. Only a turn left, and then we write our own turn right. So what happens if we go outside? So if I turn left, I'd be going up. So I want to turn left twice. I can't edit this one. Can't edit this one. Good one, I guess. Turn left. Control D I thought would duplicate, but it doesn't. So if we go outside, does it exception? Front is blocked. Okay. All right. Yeah. Well, we'll do that later. But for now, we can just go forward by 1. And technically, I don't have any turning going on yet, so I'm just going to do that and see if it works as is. So we should be able to import this. Maybe one thing is we would want a little bit of time. Delay. I'm just going to call it delay. I don't know. We may change that at some point. But let's make it so when you move, there is a little bit of waiting. So you can actually kind of see it step by step, right? So that should make us take 2 steps forwards. Really slow enough that we can actually see it. Instead, nothing happened. Would nothing happen? Oh. Well, okay, that can't have been the difference, so I must have either forgot to save or something. Yeah, so one thing is we sleep at the end, which means we don't really get to see the first one. Super ideal. Maybe we could just put a delay in the world constructor? There we go. And maybe that one should be even more. Eventually we would want like a run button or something. I'm not sure exactly how. I mean, I think the idea, like a run button, I don't think I want a button on the display. Like, I think I want the interaction to be between you and the code and the REPL and the display, not like you pressing buttons on the display necessarily. So I guess run, we don't really need a mechanism for run because we already have Control C, Control D, I think. That's fine. Okay, cool. That's working. We are starting in the top left instead of the bottom left. Maybe change that up. Let's work on turn left. Oh, yeah. Well, we'll do turn left and then we'll do the rest of move. How did it know turn left? Because of Karel? I guess because of Karel. Interesting. Yeah, I mean, I suppose, but I think starting with east makes a lot of sense since we did that before. That makes no sense. So we're just gonna update the direction. So if we were going east, we're gonna now be going north. This is another place where if we had, if I used the appropriate numbers for these, we could actually have the logic here just be like plus equals 1 mod 4. But honestly, I think I'm inclined to actually write it out because since this is a learn to program thing, I think we want to make it so that anyone actually daring to dive into the code to learn more about how it works is going to hopefully find code that's like not as difficult to understand, not as clever, perhaps. It's nice and basic, hopefully. Okay, so if we were going east, is there a way to edit the program without the CircuitPython restarting? So you totally could interact with the REPL. Without the CircuitPython restarting. I'm not sure. Like, it's probably possible in some way, but I don't have a clear idea of how it would be done. And I don't know that I will necessarily go too far looking for an idea, but if one comes to mind that seems easy, I may do it. It would be kind of hard, though, because you don't want to, like, reconstruct the world, necessarily. You would want to just, like, reset it back to the beginning of where it started and then rerun. Like, basically, you wouldn't want to rerun the entire code, essentially, right? Like, this is creating the world and doing a bunch of stuff that you would not need to do a second time, necessarily, especially if you're not restarting CircuitPython more generally. So you would somehow need to structure this differently. There's a way where you can write your code in a file and then have that file execute when you're in the REPL. So like you could have a REPL code file that does the import, and then you could be writing code here, or you could be writing code in here, and then like after the code in here runs, you're left at the REPL to be able to like experiment further. So you could do like, you know, move 5 times and then come down here and start experimenting like on the fly, and then kind of copy code back as it becomes clear that it's good or something. That's not really rerunning, but yeah. Yeah, something like that. Yeah. Your library would have to kind of be a little bit more meta than this one is. You need like one layer above what I'm building here so far, at least, to manage the running of the simulation. Whereas here, it kind of just like you import it and it runs. Okay, so if we're going east, then we change and go north. If we were going north, we change and go west. If we were going west, we change and go south. If we were going south, we change and go east. So that sounds like turn left to me. Let's fill in the rest of these. So if we were going west, then we get a -1. North, we get a y -1. And south, we get a y plus. Okay. And we don't have any boundaries or anything, so if we currently go like move, turn left, move, we are just gonna march right off the screen, I'm pretty sure. Or the move left is not gonna work. I mean, the turn left is not gonna work. And setting the Y. Y cannot be set. I did not make a Y setter. Oh, X setter, Y setter. I see. Okay. It still didn't work. Moving. Let's see if the actual direction changes. Does not. Okay. So why not? One of those. There's 0 through 3. East is 0, so 0 the whole time. Current turning from that run. Fascinating. My instinct here is that we have some multiple variables that are not actually the same or something. I believe turn left is a primitive, and it's standard to the. Yeah, I think that's true as well. Karel direction equals north. Not letting us update the direction. Direction is just a field attribute, I guess. Did I spell direction wrong? It's highlighting. Huh. World. Only one world with one Karel. No? One world? We only have one world, we only have one Karel. We only have one Karel. Why is updating the direction not working? It works right after we do it. Oh. Yeah. It's just going through all these. We need elif so that we don't hit all of these. Okay. Yes. As I was saying, it will just march right off the screen. Yes, there we go. Okay. Should we put the boundaries now? Maybe? Edit this one? No. Okay, I'm gonna make a front is blocked, and then we're going to use that inside of move to raise an exception if you try to move to a place that's blocked, which will include outside of the display bounds. So we kind of want like the whole thing, but make this XY and then X. Okay, so we have the location. We need to look in the tile grid at that location. XY. Index. And we basically want to know if the tile index. So I'm going to use this for the blocked one. That's going to be 6. But we also want to do, block row 1. We also want to do the bounds of the screen. So we're allowed to go to 0. Okay, so if 0 is greater than not self world.Karel.x, or if 0 is greater than, if either the x or the y are 0, then we are blocked. Are less than 0, but we want front lock, not this, because we're considering the location in front, not the location where we're at. If either of those are negative, then we are blocked. And then we also need if either of them are bigger than the width and height respectively, which we know is 20 and 15. At some point I'll make them variables probably, but for now I'll just hard code them. So if front lock x, which is 0, is greater than greater than 20. If it's greater than 20, that one will be 15. We are blocked. Greater than equals, because those are 0 based. Okay, now if we move, so when we move, if the front is blocked, we raise an exception. So I'm going to make a class front is blocked, because that's what this said, right? When I tried to move off. Yeah, front is blocked. So I'm going to make front is blocked exception. You really need anything? I don't know. Can you just do it without this? Lines. If front is blocked, raise front is blocked exception. L index out of bounds. Should not access tile index until we know that it's in bounds. There we go. Front is blocked exception. Okay. Cool. Maybe we should say front is blocked. Barrel can't there. Okay, there we go. And we get to see that it was on line 8 where the exception was thrown, which is cool. So like when you're learning to debug here, you kind of can see your own code lines, which is nice. Okay. Those are working. Let's make sure that the wall works. And in order to do that, I need to cheat a little bit. So I'm just gonna... Can I just use world from in here, I think? I think I can. Because world is inside there and we imported star. So I think I can just use world. World tile grid. I'm just gonna say 20 is equal to 6 because that is wall, I think. Yeah, let me do 30. Actually, let me do like 50. And let's get rid of the turn left for now. Yeah, so I was like, what's that delay? But that's because we delayed inside the constructor. Okay, so yeah, we have a wall. And if we try to move 2 more times, we should run into the wall. Didn't save. That's probably what happened before, too. Okay, there we go. Yeah, can't move there. Boom. Okay. Okay, beepers. So... Well, okay, we made front is blocked. I guess we could make a front is clear. Front is clear. Turn not blocked. Pretty easy. Beepers present. Yeah, so in order to be doing anything with that, we have also facing north, facing west, and not facing north, not facing west. I mean, technically, I could implement any of those right now-ish. I think what we should do is actually change this a little bit. Yeah. Let's refactor this in anticipation of these ones. So we're still going to have front is blocked, but we're going to have, I'll reluctantly say corner is blocked, which is going to take a corner X and a corner Y. And that way, not all of that needs to be here, actually. So front lock, front lock. Corner lock. Okay, so that takes an X and a Y, and then here we can say return corner is blocked, front lock X, front lock Y. Because then we can reuse corner is blocked for def, right is blocked. It's gonna be exact same as this, with the exception being that we add different things based on where we're facing. So this is right is blocked. So if we're facing east, where we want to be checking the block that is south of us, which means that that is Y plus 1. If we are facing west, then we want the block that is north. So basically, it looks like we might just be swapping these. If we are facing north, then we want the one that is to our right, which is actually that way. We are facing south, we want right, which is actually west, which is kind of left in a way, but it's fine. Yeah, okay. That is correct. And we probably shouldn't call it front lock here. Right lock. Okay, so if we just call that at the beginning, it should be true. Because we are at the edge. None. It return. None. Oh. Wait, right is down. Should be false. But it's none anyway. Wrong. How did we get none? Not return. Oh, we need to return false. Was I never returning false? Wait, but how did it know that it could move? Okay. Not sure how that ever worked in the past, but I guess, I mean, I must have had a false. I think. Copy it? Otherwise, how would it have gotten false and then actually taken a step? It must have been returning false. Right is blocked false, but that is actually because we were at the top and right is, well, and we're facing east, so then right is down. So really left blocked would be easier to test here. I'm going to just cheat though and say world.Karel.y equals 14. We'll move Karel to the bottom left. Yeah, and then right blocked is true because we're at the bottom. This looks similar. Yeah, so okay, yeah. Since you mentioned it, I will say shameless plug again real quick. I showed this at the beginning of the stream, so I won't spend too long on it, but I did solve, I think it was yesterday's Advent of Code where the guard was walking around, and I solved it on CircuitPython and visualized it with this bitmap here so we can kind of watch the path that the guard took. So yeah, Advent of Code I've been having fun with so far this year as well. And yeah, this does, my mind was very much in the 2D roaming around the world space, so it felt natural to work on this as well. First played with Terrapin Logo many years ago. Fun learning tool. Nice. Looks like it's stopping too soon. Well, no, I think it's stopping right because it only has 3 moves right now. So move once, move twice, move thrice. But I also don't know how long ago you said that. That might have been a few minutes ago. I did comment these two, which made it not go all the way to the block. Joined a bit late, didn't know you mentioned it. Yeah, no worries. I'm I think it's really fun. I think it's really fun, so I'm happy to bring it up and show it again. I think it's cool cool to see other folks working on it. Oh, okay, nice. Yeah. The little 2-wheeled robot that can kind of do a similar type of movement essentially, because it can move itself forward and it can turn left and right, sort of 90, I presume, with the servos there. Okay, so right is blocked. That's working. Let's do a left is blocked. And that's gonna just be flop these, I think. Intuition, is that true? So for left is blocked. When we're going east, we want to be checking. So change that to left. So we want to be checking the one above us, which is y minus 1. Yeah, when we're going west and we turn left, that's below us, so that's south, y plus 1. Yeah, when we're going north, we turn left, that's west, which is minus. Yeah, I think that's good there. Left is blocked, so let's do, before we move Karel, say left is blocked. Yeah, left is blocked, true. Right is blocked, true. And let me just do one before as well. That should be false the first time. I think we saw earlier it was. Yeah, so left true, right false, and then right true because we moved Karel. Cool. I think left and right are working. The clear versions of those are easy. Okay. Good. And then what? These will be easy. I'm just going to leave those alone for a minute, but those will be easy. Beepers. Yeah, let's do beepers. So, in order to do beepers, we need to place a beeper in the world. Beeper is index 4. So let me actually make this a beeper instead of a wall. Let's see if that works. Technically, Seagrover's robot should be able to do... Oh, that's true. Yeah, you could do... yeah, you could do other angles if you have the servos there, huh? That's a good point. All right, we have a beeper. Let me make sure that we can see the beeper through. I mean, I don't see why we wouldn't, but let's just, I want to double check and see what it looks like, essentially. You just comment that, so we can move 5. I think that should put us on the beeper, but we'll see. Yeah, okay. Blend together a little bit, which is not ideal. I guess we could maybe, the beeper could stand to be pixel or 2 smaller. I think I'm just going to leave it for right now, but obviously the artwork could be easily updated by changing the sprite sheet. And I do think maybe the beeper could stand to be a smidge smaller, but we'll leave it. Shows through, we can at least tell there is a beeper there. Somewhere along the way, we're going to need to account for the fact that there can actually be multiple beepers on the same square, but it's actually called a corner. I don't remember to call it a corner, but not right now. First, we're going to just worry about, can we even detect the beeper and pick up the beeper and put down the beeper. So, beeper is present. I think that's the first one we should do. Beepers present. Not beeper is present, but beepers present. Beepers present. Is present. So in this case, we just get the tile index like this. In fact, that's basically the same logic. We're not doing corner lock though, we're doing we are doing Karel's XY, which is in cells, corners, if that's world.Karel X. World.Karel Y. And index 4, then return true, else return false. Okay, so if we say print sound beepers present, then if we did it after we move, we should get false and then true. Okay, found beepers false. Move forward, found beepers true. Nice. And just to make sure, if we move one more, then we do it again, it should be back to false. Perfect. Could put nice pips inside the beeper, different colors. Yeah, colors would be interesting. I definitely had the idea of doing colors. So they mention, under extra features, they mention painting the corners, saying you can call paint corner color name. But I don't think it works, at least not in here. I actually tried this, right? So it says paint corner, and then you give it a color. Really hard to see. When you run it, it says found error red when expecting close parenthesis. But I mean, I'm basically doing exactly what it says. I chose red instead of blue, but it seemed to work. So yeah, at some point I might implement this. It's a little unclear to me how it's supposed to work since we can't actually see it work. Yeah, at some point I might do that. Oh, interesting. One other thing is they're putting everything inside of main, which we are not, and I mean, we can put it there, but we can't make it get called automatically. So they're putting everything inside of main, and then it never gets called, but somehow it gets run. So like when you click this, it's calling main somehow. Whereas ours, we don't really have the concept of click this. We need this to run. So if we put everything in main, we need to call main to get it to run. So I'll structure it like that, and I'll think about it. Maybe there's some way. I mean, I don't think so, because like, yeah, I don't know. Tough part of the robot implementation was controlling the brush DC motors, no steppers. Oh. Those are a deep rabbit hole in motor testing apparatus. Yeah, that would definitely be a lot trickier. So yeah, paint color, and in fact, if you did have paint color, it almost does make this behave a bit more turtle-like. It's not down at the pixel level, but it's like more similar to a turtle if you can paint. But I also did, to your point as well a minute ago, I also did think about different colored beepers. I think would be cool as well. Like maybe you could have a task that's like pick up the blue beeper and put it in the spot for the blue beeper, and pick up the red beeper and put it in the spot for the red beeper type thing. Although we would have to add a lot of logic, count for the colors. Since right now there's only like beepers present, beepers in bag, we would need to be adding logic in there to keep track of the colors, which would be totally good. Now we'll get the basics. So beepers present, that returns true, so that's working. I did do main. Does that work? It shouldn't have changed the behavior. Yeah. Okay. Pick up beeper and put down beeper. So we, I think, want Karel. Should the inventory be on the Karel object or on the world object? I mean, on the Karel object feels most appropriate because Karel is holding the beepers in the mental picture, at least. So I'm going to say beeper count is 0 to start with. And then we can implement def. I think they just called them pick beeper and put beeper, right? Yeah. It's not pick up, but okay, pick beeper. So if not beepers present, raise, we make a new exception. Class beeper not present, I mean, is the long form of the concept that I'm imagining. Guess makes it a decent name for this. Slightly more concise might be nice, but no beeper here. Okay, so if you get an exception if you try to pick up a beeper that doesn't exist. I think seems fair. I don't know if that's how this behaves, but like it should to me. Pick beeper. No beepers present. Yes, perfect. Sure that works. Beepers here, perfect. Beeper. So it won't like work, it won't do anything, but it should not raise the exception. Cool, okay. No exception. So then what we want to do is, if we get past here, we know that there was a beeper present, so we can say world.karel.beeper count +1. And then we want to change, we want to get like the tile needs to change. And this is where at some point we actually are going to want to track how many beepers are there, which I am not doing currently. But we will cross that bridge when we get to it. So let's just say world.tilegrid, world tile grid xy, which is world.karel.x, world.karel.y equals the empty space, which is 5. 0, 1, 2, 3, 4, 5. So change it from the beeper to the empty space. Pick up the beeper. We should time.sleep. Yeah, I think that's all we need to do. Nice. Okay, we got the beeper in our pocket. Well, I think they call it a bag, right? So, yeah, they call it bag. Beeper's in bag. Does that return true and false or a number? Because there's that also. Instinct is that's probably true and false. I don't know if do prints go somewhere? Bag. Doesn't seem to want to print that. Okay, so then put beeper should be pretty easy. Def put beeper. So that one, we don't really have anything to check. Oh, that's not true. We need to check if we have beepers in our bag. So maybe we should also actually probably do beepers in bag first. How do I keep losing the reference page? I swear I've opened, I just beepers, yeah, beepers in bag. I'm gonna make that return the number because 0 will be false anyway, I guess. And I think you're allowed to pick up multiples. I'm gonna make that return the number. Return world.karel.beeper count. Okay, so then def put beeper if beepers in bag is 0, raise no beepers. I mean, should that be a beeper not present also? I think I'm gonna make it more specific actually and say no beepers in bag. Class no beepers in bag. There are no beepers in Karel's. You can paint corner. Can you check the color of the corner you are on? No. Oh, yes, actually. Well, I mean, it doesn't work, so I feel the answer defaults to no since it doesn't actually work. But if we were to implement it and if we were to match what seems to be supposed to work, then yes. Uh, I mean, it's also a little unclear because they just say white, black, blue, red, etc. But there must be, if these are going to be strings like this, there has to be a finite set of the ones that are supported. And they chose not to list it here, except for with just etc. in the first four. Which, I mean, like, I'm re-implementing it. I could choose my own colors. But I feel like if this were actually intended to work, they would need to tell you the full list. I mean, they wouldn't need to tell you the full list. You could experiment and figure it out yourself, I suppose. But in the vein of being fun for a person who's learning to program, I would think telling you the full list is the right way to go. But I'm not sure how the color thing is working. But yeah, eventually we may do that. I'll have to change the way the background works once we get into that. But yeah, that'll be probably not a thing I do today, but maybe a thing that I do ultimately. I am happy with how far we've come. I wasn't sure exactly how far we were going to be able to get, if we were actually going to be able to do movement and beepers and everything, so pretty happy with how far it's come along, which does make me more inclined to look into the coloring and stuff like that, since we got all the basics done pretty much. So that will raise an exception. Okay, so if we try to put a beeper before we have a beeper, we get an exception. Put beeper. Okay, perfect. And then we should be able to put the one that we picked up. But I did not implement anything in it yet, so let's do that. So if we do have a beeper in the bag, then what we're going to do is world.karel.beeperCount minus equal 1. Get rid of one beeper, and then set the beeper at, no, set the tile at this location to be the beeper, which is not 5, I think it is 4, yeah. And we should sleep. Pretty much everything that has an action should sleep. The conditions don't need to, like, left is clear or whatever. Oh, I never called put beeper anymore. Let's move a couple more and then put beeper. And then let's move after it also. Your features are in a to-do? Yeah. There we go. Okay. We can put work. I'm going to run to the restroom. I'll be right back. Coffee's empty. We'll make it. Ooh. Okay. Okay. Facing north, south, east, west, I guess. You would expect an error in the function name, not the parameter. For the, I'm not sure what you mean. For the functions that don't work, or okay. Okay. And then there are not facings. Corner, yeah. Okay. So we have right is clear, right is blocked. Front is clear, front is blocked. Beepers present. I think I made a no beepers present. I did not make a no beepers in bag. It'll be true if that's 0, otherwise false. I think that's all the basic functions. All right, so let's see if we can make this, see if we can kind of do this one. So first, let's set up the world to look like this. Let's get rid of all of this testy stuff. I will move Karel to the bottom. We'll put a beeper at 114. And then we'll put walls at 0, 1, 2, 3, 4, and they're numbered. I don't need to count. Oh, but they're 1 based. 0, 1, 2, 3, 4, and 5. I'm gonna, like, my head is 0 based, so I know these are marked as 1, and 1 is probably simpler for people trying to understand, but in my head, honestly, 0 is just simpler. So 0, so we're gonna say 3, 4, and 5, we want to set to wall, which is make sure that that renders. Yeah. Okay, so our walls look different, right? There's don't have lines in between, and there's do actually have the pluses. But I'm fine with it. I think I like this wall better. Okay, and then we need to do what now? We're basically learning how to do a turn right. So in the last chapter, we wrote a program to help Karel climb the ledge. Okay, so we want to get to like this. So we are gonna, we wanted to get to like that. We would move one, pick up the beeper, move again. That should get us to here with the beeper in our bag. We turn left. We move. We want to turn right now, so I'm going to say turn right. We don't have, so we're going to define. Turn right as turn left 3 times. We could use for loop, but I'll just do it this way for now. So then we should still be here, but now facing right, so we can move, put beeper, no, move again, put beeper, and then move one last time. Yeah. Oh. How come we don't get to see? How come we like spawn on the beeper? The X start on 0? Because I don't know why we're not seeing any time before Karel is on the beeper. We'd be seeing that due to the delay that's in init? Because that's at the beginning. That's at the beginning, and then we move this, and then we call move, and there's no delay between those two. Okay, I see. All right, never mind that. I guess let's just do... I kind of want to see it, so I'm just going to do time.sleep delay in here. Yeah. But this gets at probably what is the next true thing to tackle here, which is how do we want to feed the input in? This is not meant to be part of the program, right? Like in this program here, there's no code that's setting up the world to look like this. The world just intrinsically exists like this on this one. Somehow, I need to make a way to set the world how it's supposed to be. I'm not sure how I want to do that just yet. But that basically factors into this in a way, because what is essentially happening is this stuff is setting the world and it's happening instantaneously. And then our next call, when this wasn't here, our next call was moving and then waiting after. So that's why we did not see any time before we were on the beeper. So that should resolve it. It's not really the ideal solution, I don't think. It's good enough for now. Oh, you know what I just noticed? When we turn, so yeah, we did solve this, but when we turn, the sprite is actually supposed to move as well. See here, the sprite is actually supposed to be turning. We aren't doing. That is going to be inside of... We actually probably want to make this a property. So I'm going to say direction underscore, well, underscore direction, and then we're going to make a property def direction return self direction setter, like new value. Self dot direction equals new value, and then we also want to update the tile index dot tile grid dot tile index, no, 0 0 equals direction, which we need to know. We either need to have an if statement, or we need to rely on the fact that the numbers are in the same order as the sprite sheet, which I don't want to do. So I'm actually going to make an if statement and just say if. Doesn't really matter if we do new value. Okay, so if we're going north, that is 1, so 0 1. If we're going east, we know that it is 0. Extra line in these. We're going south. It is 0 1 2 3. That's the upside down one. It's 0 1 2. There we go. Nice. And it did actually turn in there. It doesn't spin very long in that direction. Oh, my coffee's gone. Sweet. Yeah, and upside down works. Let's do one more to make sure that the last direction works. We'll end up on the spot above the beeper, but we'll be facing west. Our feet will be in the air. Oh. No, we're facing south, which means our feet are on the left. My bad. Yeah. Cool. All right. We have successfully caroled. We have successfully made the turn right function. Could use a for loop, but we didn't. I need to think about how I want to feed the starting state of the world into it. But I'm pretty happy. Try pick beeper? You could make a try pick beeper. Well, let me catch up here. All right, that was about the motors. Okay, yeah. Probably not using sprites to render the walls. Yeah, they might just have lines or something. Could make the icon turn pause move. The icon turn pause move. Oh, if I know what you mean. Like have a delay inside the direction setter? Oh, okay. Yeah. So if we do a sleep inside of direction, then that means when we turn right, we sleep 3 times. I don't necessarily want to think about a way, because I actually did, until we saw it turn 3 times, I actually did like the fact that it stopped and showed us the turn directions. Yeah. Just a setter, so we can't take multiple values. Yeah, I would like it to delay there. I do think that would be cool, but I don't know the right way to do it, because if we put it inside of turn left, then we're going to delay 3 times inside of turn right, which I don't necessarily want. And there's not really anywhere else. I mean, like the direction setter, we could put it there, but we just saw that that's the same problem. And really the crux of the problem is that if we pause for turn left, we're then going to pause 3 times for turn right. So then it would seem we don't want the sleep in here, but somehow we would want it like out here, which we could put the sleep here at the user level for turn right, but then turn left will not actually have any sleep. So we'd have to do that. Maybe we could take an argument here. This is not specified anywhere here, but we could say turn left takes an argument of the delay time, and it defaults to delay. And then when you declare turn right, you need to pass in 0. I don't know if I like that very much either, because we're still venturing away from this page. I would love it if you could follow this page, the code at least, with minimal changes. It's not going to be 0 changes, because we did change this, and the way that main works is inherently has to be different. So it won't be 0 changes, but I would ideally like to be minimal. You do actually kind of see that. They actually show it. They just use a faster time. Maybe that's what we should do. Maybe delay should be not as long. I mean, I guess that's good. Right? We want you to be able to see it. This whole thing, the whole purpose of this is to be a visual thing that you can code. Yeah. So I think actually delay, let's just make delay a little bit smaller and then put it in turn left. Or the direction setter? I think turn left is the right spot for it, because it's in move as well. Should be the high level interface functions that are doing the sleeping, not the lower level properties on Karel. Turn left. Nice. And I added all the stuff at the end there, at the beginning of move. That's a good thought. Yeah, that would actually solve what I was getting at. I think now that I've seen this one, though, and how it shows you the little loop-de-loo there, I'm less opposed to showing the loop-de-loo. It just felt a little slow with the 0.5 seconds I was on. I don't mind it as much with this one. Although that totally would solve it. If we put our sleep at the beginning of move, then our turns would occur instantly, but there would be a delay amount of time before we actually did the next thing, the next move, essentially. Yeah. Do it. Yep. Okay. I think that is going to do it for now. I truthfully got this a lot farther than I thought that I would in one sitting, so I'm pretty stoked about that. Yeah, I do want to think about how to feed the input state to it. I would love to come up with a way where you can feed the input state somehow, somewhat unobstructively. Maybe we'll define a JSON language for it or something, and the JSON lays out the map. Maybe something like that. I don't know. I'll think about it a little bit. Figure out how I want to feed that in. That'll probably be the next major thing I tackle, but this is looking pretty good. We actually got all of the basic functionality, not including the extra features, which don't work in their implementation either, so I don't feel too bad about that. Although I do think Paint will be kind of cool. I am thinking Paint would be fun to do, so I'll probably do that at some point. But yeah, I will let you go for now. Thanks for hanging out, everybody. I hope you all have a good rest of your day and a good weekend and all that stuff. I will be back next Saturday, I do believe, at the normal time. I think maybe deep dive next week too for me, but I'm not sure. I gotta talk to Scott. I think Scott's going out of town or something. Maybe, but I'm not. That might not have been next week. I don't remember for sure. Anyway, I gotta talk to Scott. So maybe deep dive. Maybe he's doing it. I'm not sure. If not, and I'm available, then I will. Otherwise, I'll be back on Saturday for sure, I believe. And yeah, until then, I will just bid you farewell and say see you later. Thanks for watching.